if you have considered more than one random variable, then it is called multiple random variable. Okay, so in real time actually we will be having two-dimensional signals most of the time, then we have three-dimensional. Okay, so like that we have multi-dimensional variables. Okay, so that is why multi random variables are very much important for analysis of real time signals. Okay, so that is what is that here we are discussing analysis of two random variables, that is much needed. In this topic we have discussed only the two random variables. Okay, and and here we are discussing what is the probability function for two random variables. So we have already discussed what is joint probability distribution, what is the probability distribution for single random variable. So what is the probability distribution for single random variable, how do we denote? So in the last class we have already discussed that we use capital Fx of x is used to denote what? Distribution function. This is called cumulative distribution function. Yes or no? How do you write this? It is the probability of a capital X for x less than or equal to small x. This is called a cumulative distribution function. This we have discussed in the when we have discussed about single random variable. Now we are, what is that we are doing here? We are discussing the distribution function for two random variables. That is why what is the name we got? Joint. Joint means what? So more than one random variable is considered. That is why it is called joint probability distribution function. Okay, so that is why here we are considering two random variables, so capital X and capital Y. Now what are the elements of X? The random variable we denote with capital X, no? Random variables we have denoted with the capital letters, and the elements we denote with the lowercase letters. Okay, so what are the elements of capital X will be small x, the elements of capital Y will be small y. Okay, now here we have considered two random variables. Okay, these random variables are defined in which plane? These are defined in xy plane. Okay, so then what is that we have done here? We are considering the pairs of x and y. Okay, so we have just ordered all these pairs x and y, means the order means the initial value to the final value we have taken x, and the initial value to the final value we have taken y. So this ordered x and y is called random vector in two-dimensional product space or joint sample space. Okay, so if you have only single random variable, then it is called sample space. Since we have two random variables here, what is that we call it as? We call it as joint sample space. Okay, or we also call it as two-dimensional product space. How do we call it as? Two-dimensional product space. How do you get this? We are just pairing the ordered x and y, so that we are getting this paired ordered x and y. This is called two-dimensional product space or joint sample space. Okay, so this is about x and y. Now we have considered two events. Okay, so event means what? We have interested with only some of the outcomes. Okay, so if you have, what is sample space? Sample space will have all possible outcomes. So event will be having the outcomes of the interest. Okay, so that is why what is a is defined such that x less than or equal to small x, and b is defined such that y less than or equal to small y. Okay, so we have discussed that, say for example, if you are throwing a die. Okay, so what is that outcome we'll be having? We are having outcomes are 1 2 3 4 5 6. These are the possible outcomes when we throw a die. Okay, now for example, what is our a will be here? What is that probability of getting? For example, a is defined that x is less than or equal to 3. Okay, so what is that a values? Can you tell me what are the a values now? The a values are, the a
One, two,
values are
three.
1 2 3. Okay, now what is the probability, what is that here? The probability of occurrence of x less than or equal to x means x here is 3, no? X less than or equal to x is, see here, the probability of 1, So probability of x is equal to 1. We have to consider the all elements for x less than or equal to 3. This problems we have already discussed when we have discussed about cumulative distribution function. So what is the probability of x is equal to 1 plus probability of x is equal to 2, probability of x is equal to 3. That gives us what is the cumulative distribution function or capital Fx of x, yes or no? So it is probability of x is equal to 3 like this. So what is that? It is equal to, and we know that each outcome is having equal probability. It is 1 by 6 into how many outcomes here? 3. Okay. So it is equal to 1 by 2. So what is this 1 by 2? 1 by 2 is nothing but capital Fx of x. Okay. So we have to consider all the events for which x is less than or equal to x here. Yes or no? So that is why the event A is defined like this. Prob x is less than or equal to x. B is defined as y is less than or equal to y, because we are considering what is that distribution function. Okay, so that is why we have to consider like that only. Now when to define the joint probability distribution for the event x less than or equal to x and y less than or equal to y is defined as, how do we define? Because we are considering two events, no? It is capital Fx of x comma y of x comma y. Okay, so if you have only one event, we will be writing as capital F of x will be writing. Now it is joint. It is joint probability. Joint means two events. So it is capital F of x comma y of x comma y is equal to, now what is that? Probability. Before, if you are considering only one event, then we have probability of x less than or equal to x. Now we will be having both probability of x less than or equal to x comma y less than or equal to y. So what is that? That is equal to probably, what is x less than or equal to s? Just now we have discussed x is less than or equal to x is nothing but event A, no? Y less than or equal to y is nothing but event B. So what is this? This is equal to probability of A intersection B. Okay, now this is for, so like this the joint probability distribution function will be defined like this. Okay, so what is the notation here? Capital F of x comma y of x comma y. This is the notation we use for joint probability distribution function. Okay, now here you see, for discrete random variable, if x is equal to x1, x2, so on xn, and y is equal to y1, y2, so on yn. Okay, so x values are having n elements, y values, because it is ordered. How many elements you have in x? Same number of elements you'll be having in y. Maybe the order will be different. Okay, but number of elements in the x should be equal to number of elements in the y. Okay, then the joint probability, how do we define it as? Probability of xn comma ym. Okay, probability of xn comma ym is given as probability at x is equal to, because we are taking only one element, we have not considered all the elements. Now we have to find out what is the joint probability at that particular element. The joint probability at the particular element p of x1 comma ym is equal to what? Probability of x is equal to xn, y is equal to ym. Okay, so understood here. So that here we have considered that we are for example your x is having the values 1 to 6, or say for example 1 2 3 4. These are the four values we have in x. Okay, now y is having the values like this. It is -1 0 1 comma 2. Okay, so the number of elements in the x is equal to number of elements in the y. So order, so 1 comma -1. Okay, like this the order of this will give us the joint sample space. Okay, now what is the probability of, okay, now for example x2 and y3. What is x2 and y3 is that probability of x is equal to x2 means x is equal to 2 and x is equal y is equal to 1. So we are considering only that particular element. That is why here we have equal sign. Otherwise, what is joint probability? The joint probability will be given as x less than or equal to x, y less than or equal to y. Probability of x less than or equal to x, y less than or equal to y. Here we are considering about the particular element, the joint probability at the particular location. Okay, that is why we have considered it as probability of x is equal to xn, y is equal to ym. Okay. Now the joint probability distribution function for discrete random variable is given as fx of x comma y of x comma y is equal to summation n is equal to 1 to n, summation m is equal to 1 to m, probability of xn comma ym, u of x minus xn, u of y minus ym. Okay. Now what is u? U is called step function. Similarly, if you remember what is the distribution function for single random variable, for uh, discrete random variable fx of x is given as, it is summation n is equal to 1 to n. Okay, p of xi, p of xi, and p of xi and u of x minus xi. So this is the what is that distribution function for the single random variable. Okay, cumulative distribution function. Now what is joint probability distribution function? It is nothing but two random variables here we have considered. Since we have two random variables, we will be getting step function, two step functions here. Okay, so one belongs to x and the other belongs to y. And we should also consider what is the probability of xn comma ym, both we have to consider. Here we will be considering only one. Okay, that is the difference. Similarly, for n random variables, xn is equal to, n value is varying from 1 to n. The joint distribution function is given as, so here if you are considering n random variables, before we have considered only two random variables. So if x1 comma x2 comma so on xn, because n random variables. Okay, and uh, whereas x1 x2, say in the previous class we have x comma y. Now we have n random variables, that is x1 comma x2 comma so on x3 so on xn is equal to what? Probability of x1 less than or equal to x1, x2 less than or equal to x2, x3 less than or equal to x3 so on xn less than or equal to xn. Okay, so it is same as this equation. See here, it is same as this equation. Here we have only two random variables. What are that? X comma y. Now how many random variables we have? We have n random variables, x1 to xn. So x1 is having small x1. Small x1 is having small x1 number of elements, while x2 is having x2. Small x2 are the elements of capital X2, like that. So here also we have only two, no? X comma y. Now we have n elements, that is why n random variables. That is why what is that probability distribution function is given as, see here, joint probability distribution function is given as probability of x1 less than or equal to x1, x2 less than or equal to x2, x3 less than or equal to x3, so on xn less than or equal to xn.